So, hi everyone. Just to make sure you're in the right place, you're here for do as I say, not as I do, how we build our kube clusters and why you shouldn't. I am Nick Young. To introduce myself, I have been a sysadmin for 20 years now. I've been on Atlassian's Kube team, I've been at Atlassian for 5 years and on Atlassian's Kube team since it started 3 years ago. Yeah, we've built a whole bunch of stuff in that time. So some important things as I get started. The name of our team, which will be relevant, is the Kubernetes Infrastructure Technology team. You may notice there's a redundant T there. It solely exists so that we can make Knight Rider punts for all of our repos and stuff. I firmly believe that whimsy is important in your naming schemes. So, what I'd like you to walk away with today. Firstly, what we've been trying for, we're building all our own kube clusters. What we actually did. How it went. And lastly, and the meat of the thing, why you shouldn't do the same as us. Okay, so what we were trying for. Here is what we were trying for. From the start, we wanted to build a set of clusters that eventually could run 95% or more of compute inside Atlassian. So, the number's not 100%, but it's pretty close. And so that's the key thing here. We wanted to make the whole thing fit as many use cases as possible inside Atlassian. Why did we build our own? Firstly, the tools weren't ready 3 years ago. There was just the stand me up a cluster tooling was very incomplete. To build our clusters, we literally started from Kubernetes the hard way and built from there. So our clusters are, as close to artisanal as you can get, I would say. Secondly, compliance. We knew we needed a compliance regime. It's not that long ago that we IPO'd. Now we're a public company. We got SOS controls, the same as everybody. We wanted to make sure that we could meet Atlassian's internal compliance regime, which has a couple of nifty things, but a full talk about that is for another day. Lastly, everything was still pretty new at the time, and so we wanted to make sure that we knew the system as well as possible, and that was why we started from basically Kube the hard way, was just to make sure that we knew this whole platform, every which way, upside down, back to front. So, what we actually did. Well, myself and one other guy were the ones who actually did the initial design. And so I started from my rule zero. Design out the biggest problems you know about so you can find all the new and interesting ones later. This certainly applied. We picked some problems that we knew would be a problem based on our experience running the on-demand platform. A lot of our team came from running the Atlassian on-demand platform, which used to run hosted Confluence and hosted Jira. It was a pretty big platform that used an early form of containerization in OpenVZ. And so we had experience at running quite a big fleet of stuff. And we wanted to make sure that we took as many of the learnings that we'd had from that as possible and built them into this new platform. So the problems we decided to solve were, firstly, to manage blast radius. This is the number one thing that we had learned running a big platform earlier, that you really needed to make sure that when you make changes, you can make changes to some subset of your stuff. If you're managing a full stack like we are, then having that subset be manageable is super important, and it frees you up. Keeping it orthogonal frees you up from actually, stepping on each other's toes when you're working together. So what we actually did was build a layer cake, based on your classic OSI model style things that keeps strong isolation between the layers, with a very clearly defined boundary, so that then, if I'm working on the lowest layer, someone else can work on the next layer up, and someone else can work on the top layer. We wanted to really manage dependencies. We knew that eventually 95% of computing would be running on us, so it was really important to us that we didn't depend on anything run by Atlassian that would end up running on us. Because cyclic dependencies are really hard, they give you really difficult bootstrap problems, so we tried our best to keep them cut out the whole time. Lastly, cattle not pets. We embraced immutable infrastructure as much as we could. Don't want to preempt too much, but this has been a real saving grace for us. So, the layer cake. So the first layer, we called the flag. That is a Knight Rider acronym. In Knight Rider, it was the Foundation for Law and Government who funded the whole cool truck and everything. So the important part there is that that's the base AWS config. So it has like VPCs, the relationships to VGW, security groups, stuff that we need to be there to build the next layer, but that we don't anticipate changing very often. Changing this bottom layer is a bit of a big deal. It's a bit riskier than the other ones because it affects everything all the way up the stack. Next up was the car one. If you've ever watched Knight Rider, I shouldn't need to explain that one to you. So this one has all the compute, the control plane, the etcds. Basically, all of the EC2 instances and associated shenanigans is all in this layer. The important defining part of this layer is that it stands up an API server endpoint, nothing else. That API server is a completely unconfigured vanilla API server. Because we have all the RBAC things turned on, that means that when you first stand up one of these clusters, this API server can do nothing, nada, zip. You can't even get nodes because the nodes haven't even checked in yet because they're not allowed to because the RBAC hasn't been done. That is the responsibility of the Goliath layer. Goliath was the truck. So this contains all config that actually runs inside Kube. So that includes the RBAC, the PSPs, the initial Kube network config, all of the sort of the basic stuff that paints a cluster and makes it a cluster that we are prepared to manage is in here. Plus all of the system services that we provide out to our users. Because again, the point of this platform is to be a platform that other Atlassian users can use to do what they've got to do. And so we're trying to be as opinionated as we can up to our demarcation point, which is this Goliath layer. And on top of that, we try to be relatively unopinionated and let people do their thing. They can come talk to us and say, hey, you do this stuff all the time, what do you think? But we're not going to say, no, don't do that, with some exceptions. Okay, so let's talk about cattle, not pets. So the controllers and the nodes, we are an AWS shop. So the controllers and the nodes are both created in ASGs. The controllers are cycled automatically when we update the launch config by the ASG and Terraform. Sorry, I should have mentioned that. The first two layers are Terraform. The top layer, Goliath, is Ansible rig. So this one, when we say need to upgrade Kube, the way that we upgrade the control plane is we update the Kube version inside the Terraform and push Terraform. That's it. Terraform handles creating a new ASG, make the ELB health checks, confirm that the API servers have come up correctly, and then it deposes the old one and destroys it. So for us, it's a relatively atomic operation to do a Kube upgrade. That's been really good. When we have things like the recent CVE that meant that we needed to deploy changes pretty quickly, it's really straightforward to us to do. The other thing that's good is that the other nodes, they're cycled by an autoscaler. So if we want to upgrade their version, we just change their launch config, and then the next time that they die and come back and you get new nodes, then those new nodes are the right version. So there's never, because of the cattle not pets thing, we do 0 in-place upgrades, 0 touching the instance. Touching the instance is 100% an anti-pattern. The only reason you go onto the instance at all is to figure out some curly problem that you don't have in your logs or Docker's gone weird or something like that. And that has really, really saved us so much time and heartache in the long run. It is not funny. etcd servers. Now, in terms of cattle not pets, I like to say they're like milk cows, you know the name off. You try and help them get better if they get sick, but there's a very definite time period after which you say, look, I'm sorry, I got to buy a new milk cow, you're out, right? Because the point there is, you've got to be a little bit careful with your etcds because they are the source of truth, but trying to keep them immutable is really, really helpful because it means that because they're the source of truth, you're never going to accidentally shoot yourself in the foot. And so, again, this has actually been one of the hardest parts for us to get right in our setup. It is really tricky to run etcd nodes in an immutable fashion. We have got some rules about it that I'm sorry I don't have too much time to go into right now, but grab me afterwards and I will be happy to run you through it. So yeah, rebuilding. Originally, our plan was that any significant cluster change, we would burn it down to the ground and rebuild it from scratch. And so the tooling is designed to allow us to do that in about 30 minutes. So basically, there's a build that we can do that is a destroy build that will destroy at the car level, that will destroy all the compute, and then we do a fresh deploy and we'll get all the compute back. That means, however, all the stuff that was in etcd is gone. So as we've started to take on loads that were less stateless and more stateful, and they've started to persist data in etcd that they don't want to lose, we needed to. It's harder to do that now, right? We've got to do a bit more shenanigans about etcd restores. It is possible though. So secrets. Here, this is talking about managing dependencies. For these secrets, I'm not talking about Kube secrets. I'm talking about the initial secrets that you need to actually stand up the cubes. So like, things like the CA certs for the cluster, the certs for the serving certs for etcd, because the client certs that you use to do etcd authentication, because you better be doing etcd authentication at this point. If you are not, you could possibly be in for a very bad time. It is off by default as well, so things to remember. Look at that. So yeah, we store the secrets in private S3 buckets. They're only accessible to the nodes, and obviously to us sysadmins. And then there's an init job that runs at startup on the nodes, that pulls all the secrets, puts them in the right place, and then it is a systemd unit that has that everything else has that as a requirement, so that nothing happens until that's finished. Similarly, we use ECR for image storage. We don't currently run our own private registry. Atlassian does run a private registry, but we don't use it, with the intent being that, as I said before, there's a very good chance that that registry will end up running on top of us, and we didn't want to be stuck in that situation at 4 o'clock in the morning that, oh, the Docker registry is down. Because the Docker registry is down, I can't boot new nodes because they need to pull the Hypercube images from the Docker registry. So what we do is we have some jobs that pull down specific versions of the Docker images we're going to use and push them into ECR. High on my to-do list when I get back is to mess with that build a little bit and put all of the image and vulnerability scanning stuff into that pipeline, because I think that is a bit of a hole that a lot of people have right now, and as we've seen by the node thing and a bunch of other similar attacks, that that supply chain integrity is a really, really important security hole that everybody needs to plug. So, how it went? Well, our clusters scale pretty well. Our biggest cluster size so far is about 14,000 vCPUs and 50 terabytes of RAM. And we currently have about 20. Most of them are not usually that big. That's the biggest one that runs a whole bunch of the Atlassian internal CI. It's pretty common that will, have 2,500 builds dropped onto it in a minute or two. And so it will need to scale really quickly to make sure that people don't have to wait too long for their builds. Because I don't know about you, who else are sysadmins, but if there's one thing that will make your devs come and poke you real hard, it's when their builds don't start for like 10 or 15 minutes without a good reason. And so we've spent a lot of effort to make sure that time is as short as possible. As I said, mainly batch. For now, most of our workload is batch jobs, CI builds from one internal customer or another. In October, our average was 177K pods a day, which is a little bit more, around about 2 per second. So it's a pretty respectable amount of pods, I think, overall. And what we find is that the internal workloads are super bursty. As I said, a lot of the time it'll be at 5 a.m. Sydney time. We'll often get 2,500 to 3,000 builds scheduled that will need a couple of hundred nodes added very quickly. So that's one of the reasons why we built Escalator, which is the batch optimized cluster autoscaler that autoscales nodes for us. That's at github.com/Atlassian/escalator if you want to check it out. It is definitely built for jobs that run to completion though. So it's completely not useful for stateless server workloads that are intended to stick around for a long time. But if you have jobs that are going to run for some period of time and finish, it is a very responsive elastic autoscaler that will scale you up and scale back down. I'll leave that one alone for now though. Our service workloads are coming. We have some people building a whole big teams building an internal PaaS. Some of them are here today. Hi. Basically the point of that internal PaaS is that is to have developers not need to care about how their stuff gets deployed. They'll just say, I want a Docker image, a Postgres database, and I want it to be exposed on the internet, please, in a really simple declarative file. And then there is a whole bunch of magic that the PaaS team are building that will then translate all of that through a variety of translations into actual Kube things, wire it all up for you, generate you a Postgres database, make sure that the Postgres connection strings and details are all wired up to your pod for you, so that if you're a developer, the experience of using the platform is as close as possible to the experience of running stuff on your laptop. However, some stuff has not been great. Managing etcd is hard, really hard. We've had heaps of problems with running etcd. Consensus problems with Raft, running out of IO problems can cause election storms that are not a good time. If you ever hit the 2.1 gig limit on the size of your etcd database, then your cluster will flip into read-only mode, and you will have a pretty bad day. Recovering from that is a bit tricky, and we've got extensive runbooks now on how to do it. It is really hard. I'll get to what I think you should do about that later. The Goliath layer needed a lot of work. The Ansible is really good for early prototyping, but the deployment model we originally used just didn't scale. What one of our guys had to do was to parallelize the build jobs in Bamboo, the CI tool we use, obviously, since it's ours. And once we parallelize the build jobs, it means that now we wait 20 minutes for a build, not 20 minutes for each cluster times the number of clusters. We're currently at 20 clusters and adding more. So that was a really important step for us not to be spending 3 or 4 hours a day waiting for builds. But that is mostly fixed now. Security is a challenge. Like I said, it's not really tied to design. It's going to happen no matter what you do, but it is really worth noting. Security is really hard. The other main batch workload that we use is Bitbucket pipelines. Bitbucket pipelines is Bitbucket's CI/CD in the cloud for you. I like to say to people, as the people who run the platform, it is an arbitrary remote code execution as a service. So as you can imagine, the security profile of that is pretty nightmarish. So we've had a whole bunch of problems with that we've had to fix. And it can be pretty scary. And lots of Kubernetes security things can be pretty scary. There are great options available for you in Kubernetes to tune all this stuff, but like a bunch of people have said in the keynotes and other places, the defaults are not very secure yet. So, tips. Sorry. So, here's just some general notes and stuff on things that I learned from our design that really, really worked. Firstly, manage the dependencies. Be careful about those dependency cycles. If you are going to have dependency cycles, you need to make sure that you are knowingly choosing them and that, pardon me. Sorry. You need to be careful that you are choosing knowingly to have dependency cycles and that you know how to bootstrap yourself out of them if everything is down. We chose to not have to worry about that by making sure we didn't have dependency cycles. It's okay to have dependency cycles, you just have to know they're there. Cattle, not pets. Immutable infrastructure practices will make your life easier. It means that if you need to upgrade, if you need to rotate, it's a matter of just throwing things away. And it also means that your troubleshooting time on any one issue for a single event is also bounded, because if things are going wrong and you don't know what's going on and it's the first time you've seen something, you only spend an hour or two trying to figure out what's going on. If you can't figure it out, you say aliens or cosmic rays or something, I don't know, and you blow away the instance. And then if it comes back 2 or 3 times, then you know you have a real problem. But the one time, when you're running things at scale, 0.01% things happen all the time. And sometimes they are not worth investigating. And so it lets you be careful and choosy about what you actually spend your time investigating. Use layers. When you're doing your design, when you're building anything, composability and careful interface design between sections of whatever you're building is guaranteed to increase your velocity because you can pick the thing that you're working on and know that you're only working on that. In terms of infrastructure, the natural way to do that is to use layers where you build up the layers because it's much harder to break infrastructure apart into separate modules. I mean, you should do that anyway inside the code as much as you can, but in terms of like overall deployment, it's really hard to sort of say, I'm going to deploy the etcd servers separately to the rest of the stuff because there's so many tight couplings between them. And so it's better in general to go like as a layer cake type structure, I think. Lastly, you should 100% get involved. I'm a sysadmin, not, historically not a developer, although that has changed since I started using Kube. But I got involved in the Kubernetes community literally just to show up to meetings and be like, hey, I use this thing, and I have found that, as an end user, people are desperate to hear what I have to say about things. So I would strongly recommend, even if you are just a cluster operator, I guarantee that any SIG call you dial into, if you say, I'm a cluster operator and here's some problems or some concerns or some feedback that I have, everybody will be extremely happy to hear it. So here's the here's the juicy bit, right? I'm sure you all came here to see why I think you shouldn't. It can be summarized with this. Use boring tools. Managed Kube is pretty great now. Sorry. When we started, there was no such thing as Managed Kube, really. There was very early GKE. There wasn't even Google Kubernetes engine back then. But now, between the 3 major cloud providers and everyone else, the managed Kube clusters are 100% usable, especially if you're just starting out now. If you're just starting out now, there is really no reason for you not to use one of them, whichever managed cloud provider you're closest to, or to whichever your cloud provider of choice. If there is a managed Kube solution for you and you're just starting out, it is almost certainly going to be better for you to get started with a managed Kube solution and then think about doing your own if you find you need to. I mean, the managed platforms don't claim to be all things to all people, and they're not. There is definitely stuff that you just cannot do. I mean, for us, we've twiddled every API server knob you can twiddle, and so for us, we can't go back to not being able to twiddle those things. You get addicted to the twiddling once you start actually doing it. You don't want to run etcd. That's the other reason to use a managed one, is you really don't want to have to run etcd if you have to. Running your own etcd is like running your own database 30 years ago. There is not, the software is great, definitely. The software is excellent, it is well built, it runs really well, but in the documentation for the software, there are pages and pages and pages of caveats, things you've got to be aware of. If you don't know that they're there, they will catch you. And so that's what I mean by it's like a database 30 years ago. There's no sort of, years and years and years of best practices and here's the things you've got to watch out for and all those sort of, industry knowledge that is just sitting around waiting to be used. If you do decide that you need to use your existing tooling, then COPS, KubeCon, KubeADM, they're all really good. Use one of those as opposed to doing what we did and literally starting from Kubernetes the hard way. Kelsey's not joking, it is the hard way. And the problem for us now is that we have got this whole toolchain working and it's as good as KubeADM for us, for our specific use case, And now there's a huge engineering effort involved in actually swapping over to everything else. So again, it's kind of a bit like being addicted to it because we can't give it up. So yeah, those are the reasons why I think you really should use manage things where you can. Thanks. I've got time for questions. Yeah.
What do you think the future is like when things like EKS and GKE get really strong? Do you feel like you could move into those type of managed services?
Yeah, so the question was about managed services and where I feel the future is. Yes, for us, absolutely. We reevaluate. Obviously, for us, it's EKS because we're an AWS shop. We reevaluate EKS every 6 months or so to see where it's at. We're talking to the EKS team about the exact features we want and that sort of thing. I would strongly recommend that, yeah, if you do run your own thing, yeah, keep talking to the cloud providers. If you're running anything at any scale, I guarantee you that TAMs and BDMs and stuff will be very happy to talk to you about where you feel the product is lacking. Yeah?
I'm curious about some of your comments on NCD.
Yep.
If we run Zookeeper already, is NCD harder than that?
I don't have much experience with, sorry, the question is about etcd. If we run Zookeeper already, is etcd harder than that? I don't have much experience with Zookeeper personally, but yeah, all consensus algorithms are kind of similar. You know, like if you're used to running a consensus algorithm and you have a good sense of like how many nodes you need and all those sort of things, it's probably going to be easier for you than it would be for other people. That said, etcd does have a bunch of, you know, of its own stuff that sort of make your life a bit harder. Okay, sorry. I think at the back, yeah, you were first.
Looks like you went with more clusters of relatively smaller sizes, like 20 of the relatively small clusters, as opposed to fewer, larger clusters. Was it a decision that you made during the design, or was it were you forced to go with this design because of
Yeah, sure. So the question is about cluster size. It sounds like we have lots of smaller clusters, and was that a decision during the design? So yes and no. During the design, the original intent was actually to have very small clusters, to have no cluster span and AZ boundary in AWS. So they would all be single AZ clusters, with the intent that if an AZ had problems or went away, you treated the clusters as though they were nodes in a supercluster. The intent was to use original federation to do that. We found that original federation it didn't move fast enough for us, and we had greater reliability requirements than the solution could deliver. And so what we ended up doing was changing our cluster design so that it spanned 3 AZs all the time, so that your main important control plane parts all had a node in each AZ, and that's how we sort of met our availability requirements. The cluster size, we have built them to scale. I think the number of nodes we can have is about 4,000 in each cluster. So one of the things that we found is one of the primary determinants of the scale of that your clusters can get to is actually your IP allocation strategy. Because if you're running an SDN, each node needs to have a subnet carved out for it. The size of your pool for your SDN divided by the number of nodes that you want to allow is how many pods you can have running on each node. So there's a real sort of tight coupling between those 3 numbers as to exactly how much you can scale. Sorry, does that answer your question? Yeah, thanks. I think I'll go back to front if that's okay. Right, yeah, so if we were running containers before, did Amazon ask us to run on ECS? So the containers that we were running before were not containers in the modern sense of the word. They used the same C group container functionality, but they were OpenVZ containers where it's a bit more like a chroot than a container with an image. And so it wasn't, any of the existing containerization things wouldn't have been a good fit. And basically, when we migrated away from that data center platform, part of the process of migrating away was actually modernizing the apps so that they worked in a way that was more compatible with modern containerization as opposed to this sort of very early precursor to containerization. So at the time, we were looking at Kube for some of the other advantages you get from Kube as opposed to just ECS. So that's why at the time we didn't really look at it. Yeah. Sorry, I think go in front and then at the back.
Yeah, I had a similar question about the number of clusters. Can you give us an idea on what use cases each individual cluster would have, why there would be so many?
Yeah, sure. So the question is about the number of individual clusters and what use case we have for each cluster. So the way that we designate, so when I talked about the bottom layer, the flag, the way that we break up divide the clusters is via a 3-tuple of information. There's the internal customer name, an internal customer environment, and the AWS region. And so the intent being that we could have, we have the Bitbucket Pipelines clusters. We can have a Bitbucket Pipelines customer that has a dev environment in US East 1 and a dev environment in US West 2 and a prod environment in US East 1 and a prod environment in US West 2. And then we can have a different customer, the PaaS customer, that also have their own set of all the levels that they want in all the regions that they want. And so that's one of the reasons we've ended up with a proliferation of things, is that we've got a few internal customers now and they all want different regions or different levels or different environment names. It's not actually that each of them is very big, it's that these are administrative distinctions between the clusters. And the good part about that is that it lets you do, it makes the clusters more, the security boundary easy to understand. Sorry, I think there was one person over there. Yep, sorry, and then you're next.
You mentioned about Hypercube. How are you setting up those clusters? You're not bringing up each component to API server?
Sure. Yeah, so the question is about exactly how we're bringing up the clusters. So yeah, the flag layer, just as I said, does the initial VPC creation and stuff. That's with Terraform, and then with Terraform in the car layer, it literally just blats out all of the compute. And the good part about Terraform is that it deduces a lot of the dependencies based on how you use outputs from Terraform modules. And so we've set up dependencies and stuff so that the etcds come up first, the API servers come up after that. So we use controller nodes which run the API server, the controller manager, and the scheduler. And then we have separate etcd nodes that handle the actual secret storing. And then there are multiple pools of worker nodes that can scale to different sizes. Sorry, does that answer your question? Yeah.
Of the layers in that cake, which ones does your team manage and is on call for? Which ones do you delegate to your customers?
So the question is, out of the layers in the cake, which ones does our team manage and which ones do we delegate? Our team, those are the 3 layers that we actually manage. We are on call for all 3 of those. The delegation to other teams is usually about what they build after Goliath runs. And so part of what we do with Goliath is, say, if someone says, hey, I'd like a namespace in a cluster, then we will create the namespace for them and ensure that that super basic stuff is wired up and make sure that they have a namespace admin service account. And then after that, it's on them what they do with it. We sort of say, hey, it's up to you, but come and talk to us to see what you want to do. Yes, sorry. Then.
So that you had some pretty detailed runbooks that you guys come up with to deal with some of the operational things.
Yep.
Are you concerned with turning that over to a PaaS offering of Kubernetes? Like, I don't know what your relationship is with consumers of your Kubernetes service and what that contract looks like, and the 2.1 gig limit on etcd.
Sure. So the question is about, are we concerned about turning over? Are we concerned about turning over control to other people? The intent is actually that we will never turn over control of those things to other people. When other customers are using the platform, we are still on the hook for the operation of the platform. So our SLAs are all about availability of the API servers and whatever metric the customer cares about. So in the case of the CI, the metric is actually time to schedule for pods. In the case of sort of stateless long-running service customers, the metric is like the uptime of the services that are running on the platform. Does that answer your question? Yeah, cool. So I think one up the back there.
Yeah, you were kind of etcd limits on the number of objects you can store 10,000 objects, that just works, 5,000, 4,000.
So the question is about have we run into any etcd limits on the number of objects? I would say no. The limits that we have run into have been the size limits. And I say that as someone who had a cluster accidentally have 80,000 namespaces. The good news is Kubernetes does work when you have 80,000 namespaces. etcd does not. 80,000 namespaces, 100% will take up your 2.1 gig. At about 50,000 namespaces, your etcd will start slowing down and you'll see weirdness. And then eventually when your etcd fills up, you will have a bad day. And you will have to, if you're lucky, flip traffic to another cluster while you sort out that problem, which is what we actually managed to do. I was very glad that we took that customer into having a failover cluster ready to go. Yes, sorry, was there someone over there? No? Okay, sure.
Do you retire every cluster? How often do you do that?
Do we retire clusters? We don't retire clusters very often unless we determine there's no longer a need for them. That said, we found that one of the dev clusters that we stood up recently, that no one was using it, so we have retired that one. But that's the only one that we've actually retired since we started standing them up. Yeah, most of the time people want to use them. Sorry.
You talked about failover of the clusters. Are you running clusters active passive?
Yeah, so right. So the question is about failover and are we running clusters active passive? So yes, what we try and do is make it so the customer gets to decide exactly how they're using the clusters. As far as we're concerned, they are active, active, active. Everything always got to be up. We're in our internal sort of priority classification, we're a tier 0 service. We're 4 or 5 nines of reliability depending on which customer you're talking to. But the intent being that customers need to have a way to be able to flip to another cluster if they need to. The way that we actually do that is we have a cluster registry running, and there's ways that we can poke that cluster registry to say, hey, for this customer, you should direct your traffic over there. Only some customers have started using it because it's still pretty new, but we're hoping that that will be the way that we can sort of guide traffic without people needing to be woken up even, ideally.
So when workload is scheduled, it's scheduled in both clusters?
No. So people only schedule, most customers that we have now will only schedule load in one cluster. And so if there is a problem, it's literally just, we ask them to, currently we have to ask them to change their tooling to flip to another one. We want to move to cluster registry so that we can do that without, we'll obviously call them and tell them, but we don't need them to make changes.
So failover will help new workload continue working, but old workload will be kind of...
Yes, yeah, and that's what we found. I mean, generally, if you're having a bad enough problem that you'd even consider failing over, people would prefer to have some workload working than be too concerned about the stuff that is broken already. We have found. I think there was one other person behind there, and then you're up next, man. Okay, so the question is about what are the requirements we have that we can't run on managed service yet. Most of them are around messing with the API server, turning on experimental features. For a while, we needed to add a bunch of settings about webhooks and things like that. Most of that stuff is defaulted on now. So some of that has gone away, but one of the things about having a PaaS, people developing a PaaS on us is a lot of the time, thanks for this guys, they want the newest, hottest bits of Kubernetes, or they've submitted patches upstream to Kubernetes and they want they want their patches as soon as possible. So we've got to keep rolling forward. Yep, sure.
So in that scenario, active passive or failover between clusters, do you provide any tooling for customers to synchronize data like config maps, secrets?
No, that is a specific sort of contract of the platform, is that if you store stuff in the cluster, it's up to you to make sure that it ends up in both places. It's up to your pipeline. Cool. I think we're out of time. I am happy to take some more questions. I'll be just outside once I've packed up.